Good morning to all. Today we are going to see about Java programming language. Here we will briefly see about history of Java and Java futures, the various concepts of Java programming. Now we will see about what is meant by Java programming language and its history. Java programming language was originally developed by Sun Microsystem, which was initiated by James Gosling and released in 1995 as a core component of Sun Microsystem. Java is popular. It's a high-level language. It's an object-oriented programming language, originally developed by Sun Microsystem and released in 1995. Currently, Java is owned by and more than 3 billion devices run Java. Java runs on a variety of platforms such as Windows, Mac OS, and various versions of Unix and Linux. Java is used to develop numerous type of software applications like mobile app, web app, desktop app, games, and much more. Okay, the various features of Java are Java is a object oriented, Java is a platform independent, Java is a simple, secure, Java is a architectural neutral, Java is a portable, Java is a robust language, and it supports multi-threaded, and Java is interpreted and a compiled language. Java provides high performance, and Java is a distributed, and Java is a dynamic language. These are the various features of Java language. First, we see about what is meant by object-oriented. Java supports object-oriented. In Java, everything is object. Java can be easily extended since it is based on object model. And next feature is platform independent. Unlike many other programming languages, including C and C++, when Java is compiled, it is not compiled into platform-specific machine, rather than into a platform-independent bytecode. The bytecode is distributed over the web and interpreted by the virtual machine on whichever platform is being run by operating system. And Java is a simple language. Java is designed to be easy to learn. If you understand the basic concept of object-oriented programming, Java, it would be very easy to master. Next feature is Java provides a secure feature. It enables develop virus-free systems, and authentication techniques are based on public key encryption. And next feature is Java is a architectural neutral. Java compiler generates the architectural neutral object file format, which makes the compiled code executable on many processes with the presence of Java runtime system. Next feature is Java is a portable. Being architecture neutral and having no implementation depends aspects on specification makes Java portable. Compiler in Java is written in ANSI with a clean portability boundary, which is a POSIX subset. And next feature of Java is a robust language. Java makes an effort to eliminate error-prone situations by emphasizing mainly on compile time error checking and runtime error checking. And next feature we will see about multi-threading. When Java multi-threaded feature is possible to write programs that can perform many tasks simultaneously. This design feature allows us developers to construct interactive applications that can run smoothly. Next, Java is a compiled and interpreted language. Java bytecode is translated on fly native machine instructions and are not stored anywhere. The development process is more rapid and analytical since the linking is an incremental and lightweight process. Next, Java feature is a high performance. When we use just-in-time compiler, Java enables high performance. And we already know Java used in internet. So the main feature of Java is a distributed. Java is designed for a distributed environment of the internet. And it's a Java is a dynamic language, is considered to more dynamic than C and C++. Since it is designed to adapt to avoiding environment, Java programs can carry extensive amount of runtime information that can be used to verify and resolve access to objects on runtime. These are the various features of Java we have seen. Next, we are going to see about Java concepts, that is object-oriented concepts. Java supports mainly for these object-oriented concepts. They are abstractions, data abstractions, encapsulations, inheritance, polymorphism. Okay, and the first concept is data abstractions. Using simple things to represent complexity. We all know how it works. In order to employ in Java, abstraction means simple things like objects, classes, and variables represent more complex underlying code and data. This is important because it lets you avoid representing these repeating the same work multiple. Okay, next concept is encapsulation. Encapsulation is a protective barrier that keeps the data and code safe within the class itself. We can then reuse objects like code components or variables without allowing open access to the data system wide. We can achieve encapsulation using access specifiers in Java or private, protected, and public. Next concept is inheritance, a special feature of object-oriented programming in Java. Inheritance lets programmers create a new classes that share some of attributes of existing classes. That is deriving the properties of one class to another class. Next concept is a polymorphism. Polymorphism is nothing but the ability to take more than one action. In Java, to mean different things in different contexts. One form of polymorphism is method overloading and method overriding. Here we see inheritance in Java is a mechanism in which one object acquires all the properties and behaviors of parent class. It is important part of object-oriented programming system. The idea behind inheritance in Java is that you can create new classes that are built upon existing classes. When you inherit from an existing classes, you can reuse methods and fields of parent class. Moreover, you can add new methods and fields in your current class also. Inheritance represents is a relationship which is known as parent-child relationship. Why we use inheritance in Java? For achieving method overloading, that is method overriding, that is runtime polymorphism. For code reusability, we use inheritance in Java. There are various types of inheritance available in Java. They are single inheritance, multi-level inheritance, hierarchical inheritance, single inheritance. When a class inherits another class, it is also known as single inheritance. Java supports only 3 types of inheritance. That is a single, multi-level, and hierarchical. But Java does not support multiple inheritance. Next, we are going to see about multi-level inheritance. When there is a chain of inheritance, it is known as multi-level inheritance. Next, hierarchical inheritance. When 2 or more classes inherits a single class, it is known as hierarchical inheritance. This is a diagrammatic representation of single inheritance. When a class is derived from a single class is known as single inheritance. Multi-level inheritance, when a derived class is derived from another derived class, is known as multi-level inheritance. Next diagram is a hierarchical inheritance. When a 2 derived class has a 1 base class, when a 2 derived class is derived from 1 base class is known as hierarchical inheritance. When one class inherits multiple classes, it is known as multiple inheritance. When combination of one or more inheritance is known as hybrid inheritance. In Java, multiple inheritance is not supported by Java. Why? Because multiple inheritance is a future of object-oriented concept when the class can inherit properties of more than one parent class. The problem occurs when there exist methods with the same signature in both the superclass and subclass. On calling the method, the compiler cannot determine which class method to be called, and even on calling which class method gets the priority. When the child class extends from more than one superclass, it is known as multiple inheritance. However, Java does not support multiple inheritance. To achieve multiple inheritance in Java, we must use the interface concept. And what is before going to implement in multiple inheritance in Java, before we going to see about interface in Java. An interface is in Java is a blueprint of class. It is similar to class, but class is a collection of methods and data. But interface contains only abstract methods. That is a difference between class and interface. The interface in Java is a mechanism to achieve abstraction. There can be only abstract methods in Java interface, not method body. And that is method definition. It is used to achieve abstraction and multiple inheritance in Java. In other words, you can say that interface can have abstract methods and variables. It cannot have a method body or definition. Java interface there are reasons to use interface. It is used to achieve abstraction. By interface, we can support the functionality of multiple inheritance. Here the example interface backend, we have only that is abstract methods. Public void connect server is a abstract method, but interface contains only abstract methods. Here next interface can be implemented by using a class. Here we use interface backend. In interface contains only abstract methods. Here in this program, class front end is a super class, and class language is a another class which extends front end and implements background, and that backend is a interface which contains only abstract methods. By using interface, we can achieve multiple inheritance. Java does not support multiple inheritance because there is only one superclass. It can be implemented by using interface. Next we are going to see about polymorphism in Java. The polymorphism is nothing but ability to take more than one action. In simple words, we can define polymorphism as the ability of messages to be displayed in more than one form. Polymorphism is considered one of the most important features of object-oriented programming. It allows us to perform a single action in different ways. In other words, it allows to take more than one actions. The types of polymorphisms are divided into two types. First one is compile time polymorphism. Next one is runtime polymorphism. Compile time polymorphism is also known as static polymorphism. This type of polymorphism is achieved by method overloading or operator overloading. But here in Java does not support operator overloading. It supports only method overloading and method overriding. Method overloading is nothing but when there are multiple functions with same name but different parameters. then these functions are said to be overloaded. Functions can be overloaded by changes in the number of arguments and changes in the type of arguments. This is known as method overloading. Next, we are going to see about runtime polymorphism. It is also known as dynamic polymorphism or dynamic method dispatch. It is a process in which a function called to the overridden methods is resolved at runtime. This type of polymorphism is achieved by method overloading, method overriding. On the other hand, when a derived class has a definition of for more than one member function of base class, the base function is said to be overridden. This is the example of polymorphism in Java. Shape is a superclass. Circle, triangle, and rectangle are subclasses, which is derived from a base class, that is shape. In this coding, here shape is a superclass. Here we are having three classes that extends shape. The classes are rectangle, circle, triangle. In shape class, we having a draw method. In subclass also we are having a same method and same parameter, but here methods are overridden by using a runtime polymorphism concept. Here draw method overrides the base class methods. This is the example for polymorphism program. Thank you.